Students, the Earth is not perfectly spherical in shape. It is flattened at the poles and bulges out at the equator. So the equatorial radius of the Earth is greater than its polar radius. Now, since we know that G is equal to G multiplied by M divided by R square, therefore, G is proportional to 1 by R square, since we know that G and M are constants. Students, this shows that the value of G is inversely proportional to the square of the radius. Number 1, as the value of R is greater at the equator, the value of G is the least at the equator. And number 2, as the value of R is less at the poles, the value of G is the greatest at the poles. Experimentally, it has been found out that at the poles the value of G is equal to 9.83 meter per second square, and the value at the equator is 9.78 meter per second square. Dear students, now let us find out the value of G according to the altitude. Students, the places at high altitude are far from the center of the Earth. Suppose a mountain peak is at a height h. Then the total distance from the center of the Earth is equal to r plus h. The place at a low altitude is the one nearer to the center of the Earth. Here, h is equal to 0. Then the distance from the center of the Earth is equal to r plus 0, which is equal to r. Therefore, here G is proportional to 1 divided by r square. But at the mountain, the distance from the center of the Earth is equal to r plus h. Then G will be proportional to 1 divided by r plus h whole square. Dear students, at a high mountain, G is low, whereas at the sea level, the value of G is high. Thus, G decreases with altitude.